Today we're doing longest common prefix, Leetcode problem 14. I'm going through the top interview questions on Leetcode. I'll share a link below. This is a Leetcode easy. So write a function to find the longest common prefix string amongst an array of strings. And so if there's nothing in there, there's no common prefix, return an empty string here. So here's an example. Given this list of strings, stirs, out of these three words, you would find FL as the longest common prefix. And the reason is because they all share the letters FL, and it's in the very front of each word. So if we look at the second example, between dog, race car, and car, there is no longest common prefix. Even if it was race car and car, there would still be no longest common prefix because it's a prefix, right? It comes before. So the word car might be shared between these two words, but car is not at the front of race car. So what you could do is you could brute force, like the brute force solution for this is probably to iterate through the strings array, and for each word that you're at, you take a look at the letter and you compare it to all the other words and see if that letter exists. Then you can build up your longest common prefix as you go. But that takes a long time. That would be like an O of n squared solution, right? Because you have one loop going through the words, you stop at each word and you compare that letter or that longest common prefix you're building up to all of the subsequent words. So we don't want that. There's a better solution. Let's talk about that solution right now. The idea here is to start with your longest common prefix as the first word in the list itself. You move on and you start to cut away at the longest common prefix until it matches the current word that you're at. So let's look at an example here, right? Given these three words, you would first start with flower as your longest common prefix. And when you move on to the second word, flow, you would compare flow with flower, and you would check to see if this prefix, this entire word itself, is inside of flow. If it isn't, then you would cut away at the letter R, right? You cut away one by one at a time. You check again and you see if flow, is contained in flow. Well, that's not true either. So you cut away one more time. And now it's flow, and you see that, hey, these do match. Let's move on to the next word in the list. And the next word being flight. You repeat the same process, and you see that, hey, does flow exist in the word flight? It does not. So you cut away one letter. You check if flow with no W is in the word flight. It does not. And you cut away again until finally you see that, hey, FL is within the word flight. And you've also checked through all the words. So now you're done. And you can just go ahead and return this longest common prefix. So let's go ahead and code that up. And it might make a little bit more sense as I'm doing it, right? So first thing we can do is let's write some error checking. So if length of strings is equal to 0, like it said here, let's just return an empty string. What's another case that we can think of that might save us some time? I think if there's only one word in the list itself, we can just return the word, because that means that the entire word itself is the longest common prefix, right? If they gave me just the word flower without flow or flight in this example, then the longest common prefix is flower. So if the length of strings is equal to 1, we can just return strings at index 0, right? Okay, so we should define our longest common prefix, LCP, as strings at index 0, because that's the first word. if we've already have the first word and we've considered it, when we're looping through, let's just start at index 1, right? So I equals to 1. The reason we're doing that is because we're skipping over the first word, which is already contained in here. We don't need to consider it anymore or compare it to anything, because that's the value that we're starting with. We're going to cut away at it, possibly, until we find our longest common prefix. So we're going to iterate, I don't know, while I is less than the length of strings. What we're going to do here is well, first let's just add this so we don't forget to increment. And here is kind of where the logic happens, right? What we're doing here is we're checking, hey, well, actually, before I do that, to make it a little clearer, let's grab the actual word itself. The word we're dealing with, the current word, is strings at index I. While word.find LCP does not equal 0, and I'm going to explain this in a second. LCP equals CP. We're going to cut away at it with a slice, right? And so what's happening here, right, is this function is a function in Python that checks to see in a string, do you have this substring, right? So what this is saying is if the word does not find this substring, then it's going to return -1. And when it returns -1, it goes in here, and we cut one letter off from the substring, right? Remember earlier we started off with the word flower. So when it checks flow with flower, this is not going to be, this is going to be true because it's not equal to 0. It only equals 0 when the word finds the substring. It cuts off a letter, and then we keep doing that until we get to FL, right? And so that's what's happening here. That's what this condition is checking. And what happens on line 14 is we're just taking a slice. In Python, you can do this, this thing called taking a slice. That's what this colon marks. And it basically just sets the longest common prefix to itself up until the very end -1. It's exclusive here, right? So if this is the last element in the string, it cuts away the last element. And so here we should be leaving that loop. Now we're at the original while loop. We increment 1. When this finishes, we should just return our longest common prefix. And let's add a space so it's a little bit more readable. And let's run it. Cool. So let's go ahead and submit this, see if that worked. Great. So this is better than the O of n squared solution. You do have this loop in here, but we are more concerned with looping through the arrays itself. So it's technically still a O of n solution, even though you're doing some kind of like string manipulation in here, where you're cutting away at the longest common prefix. Hope that helps. Thank you.